Your directory table just returned 0 rows for files you uploaded minutes ago. The problem? Directory tables don't auto-refresh. They cache metadata until you explicitly tell them to update. Let's explore. You'll learn how to manage unstructured data in Snowflake using directory tables and the REST API. We'll cover setup, file operations, and processing with Python UDFs, plus a real production incident you can avoid. Directory tables expose file metadata in stages as a queryable table, with columns for path, size, and modified. You enable them with the directory option, then query like any table. But they cache metadata, so you must refresh after file changes. Let's create an internal stage with directory table enabled, then query it and filter by size and date to find large files ordered by last modified. The first block creates a stage with directory table enabled. The second queries files larger than 1 MB, sorted by last modified. Snowflake's REST API lets clients upload and download files via /API/v2/ statements with an auth token. The file lands in a stage with a 128 MB per request limit. Use for small files and integrations. For large, use SnowSQL PUT. This curl command uploads a local CSV file to the stage. The response includes status and path. When writing a SQL query, you can use a Python UDF to read files from stages. Specify the imports clause to bring in libraries like pandas and PyPDF2 for processing. These UDFs run on Snowflake's compute, so note the 60-second timeout per invocation. This UDF counts rows in a CSV file from a stage. It downloads the file, parses it, and returns the row count excluding header. Follow these best practices. Point directory tables at a stage only when you need them, refresh after file changes, and automate with tasks to keep metadata current. This task refreshes the directory table every 60 minutes. You can use event notifications for more timely updates. Choose the right method. Copy into for structured data, Python UDFs for binary files. Note the REST API has a 128 MB limit. For files over that, use SnowSQL or external stages. Then batch small files to produce process data. This loads CSV files matching a pattern into a table, skipping headers and continuing on error. Secure stages and directory tables with role-based access control. Control read-write access for REST, apply network policies, and rotate tokens regularly. Grant usage on the database, schema, and stage, plus read on the stage for directory table queries. Here's the chain reaction. Files were uploaded to the stage, but the directory table was never refreshed. The query returned stale metadata, showing 0 rows, so the pipeline skipped the new files. The fix: add an explicit alter stage myUnstructured stage refresh after uploads, and automate it with a task. Now the directory table returns the correct rows. The mistake from the incident was querying the directory table without refreshing after upload, leaving metadata stale and new files invisible. The fix adds an explicit alter stage myStage refresh before the select, which syncs the directory with new uploads and reveals the files. The REST API PUT fails with a 413 error because it has a 128 MB limit. For larger files, use SnowSQL PUT, which avoids that limit by using Snowflake's large file transfer protocol. Granting all privileges, especially to public, exposes your stage to unauthorized access. Instead, grant only usage to the specific role that needs it, like data engineer, to enforce minimal privileges. To debug directory table issues, check row count, refresh the stage, list files directly, and verify grants. Time for interview questions, including the 128 MB REST API limit. FAQs cover the 128 MB upload limit, directory refresh, and Python UDF imports. To recap, directory tables require explicit refresh, use the REST API for small files, leverage Python UDFs for processing, and automate refreshes to avoid stale metadata. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.